It's time for the moment you've been waiting for.
Hi, my name is Maddie.
I'm Jackson.
I'm Abigail.
And I'm Corey, and our group is the Concrete Canoe project for FEDD. The first thing to do was carefully read the project description and restrictions. To win the competition, your boat had to hold the most amount of weight before sinking while complying with the rules. The rules consisted of a maximum of 18-inch length, a 6-inch width, and a 5-inch height. The concrete must be made of water, cement, and aggregate, the exterior surface must be smooth, the boat must have a V-shaped bow, stern, and cross-section, the boat must not be sealed using a waterproof material, and it all must be under $40. After fully understanding what we could and could not do, as well as our goal, we went on to research concrete and boats. We found out that concrete is a mixture of water, cement, and aggregate. Cement is basically a water-activated glue which holds all the aggregates together. The aggregate is the material that takes up most of the volume of concrete, usually being gravel or sand. Boats work by displacing their own weight in water. The more weight you add to the boat, the more water it must displace to counteract the additional weight.
We figured that the best boat would be one that maximizes the volume of water it could displace but minimizes its own mass. We used two methods to reduce the mass of the boat: reduce the density of the concrete and reduce the wall thickness of the boat. To reduce the density of concrete, we needed an ultra lightweight aggregate. We originally tried blended styrofoam, but we quickly dropped that idea because it was incredibly messy and didn't give us the density we wanted. We then shifted to using glass microspheres, which are ultra lightweight, microscopic, hollow spheres of glass. We ended up using 5mm thick walls on the boat. Concrete this thin is prone to breaking, so we added chopped fiberglass into the mixture, making our concrete glass fiber reinforced concrete, or GFRC. This type of concrete resists crack propagation, shrinkage, and slump. To maximize the water displacement of the boat, we designed the boat up to 3mm of the maximum dimensions allowed and also reduced the V-shape as much as we were comfortable with. To actually achieve the geometry we designed on the computer, we used 3D printed molds. To process the molds, we sanded them, sprayed polyurethane on them, applied mold release wax, and lastly applied canola oil. This was to ensure the concrete would not stick to the molds. To test all of our design decisions, we printed small molds which produced 50 by 85 by 5mm thick slabs. We destructively tested all of these slabs to find a light yet strong mixture. The engineering design cycle is a simple idea starting with asking, what should our design do? Then coming up with ideas, planning those ideas, creating those ideas, improving on those ideas, and then the cycle continues. We iterated the engineering design cycle countless times. Like mentioned earlier, we had originally used styrofoam as our aggregate, but after testing, we decided it was not good enough for us. We also iterated on the design of our molds. Our first test molds used a spray primer and filler to mask the 3D printing imperfections, but since it didn't seal the plastic mold, the calcium hydroxide in the concrete destroyed the integrity of the plastic.
In addition to testing slabs of concrete, we wanted to test our molding technique, so we printed a miniature boat mold. This boat turned out well, and it validated our design, at least on a small scale. Once we had printed and processed the full-scale molds and settled on a mixture, it was time to mold the final boat. Once the boat was released from the mold, patching and filling the defects was necessary. After curing, we had to extensively fill and sand the boat. After many days of this, we were able to paint and apply decals.
Our full-scale mold was warped by the pressure of the concrete during molding. The mold warped outwards near the center and pulled inwards near the ends. On one of the ends, the gap between the two molds was too narrow to place concrete and had to be left empty to be fixed later. Near the center, the walls were significantly thicker than designed and had to be reduced with a rasp. After everything was complete, the boat was about 1.26% too short, 1.07% too wide, and 0.16% too short. We also had a challenge with removing the core mold from the boat, so it had to be destroyed to take it out. Luckily, we designed the cavity mold to come apart into 3 sections, so there was no challenge to remove it.
At the competition, our boat held 5.614 kilograms, or about 12.4 pounds, approximately double that of second place. We achieved first place in not only the afternoon session that we attended, but also the morning session. In addition to winning, many people complimented on our boat's design.
Oh, no, come on, we still got it. We still have it.
We do.
We still have it.
A little bit more, man. Keep it going. A little bit more.
We still have it.
Until it submerges, you're good.
Wow. God.
What a rush. Are you guys ready?
Yeah. Maybe your idea of the heavy, the marbles not mattering.
Oh, 5.6.
Hey.
Yeah, 5.6.
300 grams more than what I had.
You have 5.3? Wow, yeah, get the weight in there. Yes. Thank you. I appreciate it. Wow. I'm posting that one later.
Compared to other teams, our team started as soon as the requirements were given out. The professors of E101 will explain how important it is to factor in time for fixing prototypes that are not functioning or dealing with any other last-minute errors on the project. Once you get to the end of the semester, there will be a lot going on with other classes such as projects and exams. Having the FEDD project completed and functional is important so that all classes get an adequate amount of attention. In terms of the boat itself, you could spend more time than we did to try to further reduce the density of your concrete. You may also try to reinforce the mold to prevent warping. Also, the core mold should be able to come apart into sections like the cavity mold to assist in removal.